The history of solving the cubic equation and world events of that time by Ruth Matthews, OCU STEM Math 570, The History of Mathematics. My research paper revolves around the solving of the cubic equation and the world history at that time. The solution of the cubic equation was one of the great intellectual achievements of its time. But not like any other event in human mathematical history, the solution to the cubic equation is shrouded in obsession, competition, and betrayal. Cubic equations were known to ancient Babylonians, the Greeks, the Chinese, the Indians, and the Egyptians. Babylonian cuneiform tablets have been found with tables for calculating cubes and cube roots. The Babylonians could have used the tables to solve cubic equations, but no evidence exists to confirm that they did. In the 5th century BC, Hippocrates reduced this problem to that of finding two mean proportionals between one line and another of twice its length, but could not solve this with a compass and a straight edge construction, a task which is now known to be impossible. Hippocrates, Menaechus, Archimedes are believed to have come to solving the problem of doubling the cube using the intersecting conic sections. However, the Greeks may have been thinking about cubic equations or just problems that can lead to cubic equations. In the 11th century, the Persian poet-mathematician Omar Khayyam made significant progress in the theory of cubic equations. In an early paper, he discovered that cubic equations can have more than one solution and stated that it cannot be solved using a compass and straight edge constructions. He also found a geometric solution. In his later work, the treatise on demonstrations of problems of algebra, he wrote a complete classification of cubic equations with general geometric solutions found by means of intersecting conic sections. Leonardo di Pisa, also known as Fibonacci, was able to closely approximate the positive solution to the cubic equation, which differs from the correct value by only 3 trillionths. In nothing less than a detective story, the mystery of the solution of the cubic equation begins with Italian mathematician Scarpino del Ferro. Del Ferro found a method for solving a class of cubic equations, namely those in the form of x squared plus mx equals n. It turns out that all cubic equations can be reduced to this form if we allow m and n to be negative. But negative numbers were not known to Del Ferro at the time. Del Ferro did not publish his achievement, keeping it secret until just before his death, when he told his student Antonio Fierro about it. Tartaglia was another Italian mathematician and engineer. As a child, Tartaglia was maimed when French troops overtook Brescia. He was also known as the Stammerer because after his injury to his jaw, Tartaglia never regained clear speech. In about 1535, Tartaglia, with knowledge he had in part gained from Zuyne de Coy, openly claimed to have discovered an algebraic solution to the cubic equation. This rattled the very competitive nature of the time. Upon hearing of Tartaglia's claim and thinking Tartaglia certainly must be bluffing, Antonio Fierro challenges Tartaglia to a public contest of solving the cubic equation. Literally the night before the contest, Tartaglia was successful using Del Ferro's rule for solving the cubic equation to come up with a solution. Fierro gave Tartaglia 30 problems, all of which he could solve. Tartaglia had picked problems from different areas of mathematics and mechanics, and Fierro was not able to solve the problems he was given. Happy with the disgrace he had brought upon Fierro, Tartaglia relinquished the monetary prize of the competition. At this point, a very well-known medical doctor, astrologer, philosopher, and mathematician, Girolamo Cardano, enters our story. Not known for his discretion, Cardano starts courting Tartaglia in an attempt to weasel the solution to the cubic equation from Tartaglia. At first, Tartaglia didn't consider sharing the solution, but Cardano wined and dined Tartaglia into revealing the solution under the premise that he would keep it secret under sworn oath. Cardano succeeded in expanding Tartaglia's solution, and Cardano apparently felt at that point his oath to Tartaglia was no longer valid. Cardano published his book, Ars Magna, and in it appeared Tartaglia's solution to the cubic equation. Of course, Tartaglia was furious, but there was little recourse. To make matters worse, one of Cardano's students even accused Tartaglia of plagiarism. Putting the discovery of the solution of the cubic equation in perspective of what was happening in the world historically adds a whole other dimension to this discovery. England was experiencing the beginnings of Reformation. Henry VIII was the ruler of England, and in a dispute with the Roman Catholic Church over divorce, Henry VIII split with the Roman Catholic Church, forming the Church of England. At this time, it was the birth of Queen Elizabeth, the future Queen Elizabeth, in 1533. Magellan in 1520 to 21 had circumvented the globe for the first time. This era saw European states expanding their horizons as they established colonies around much of the world. Colonization disrupted the cultures of many nations and forced their citizens into slavery. In the field of science, Copernicus, a Renaissance mathematician and astronomer, was making his mark reviving heliocentric theory. Fearing punishment from the Christian Church, Copernicus delayed publishing De Revolutionibus until near his death. As expected, the Church opposed Copernicus's work. However, it is Copernicus's work that laid the foundation for modern astronomy. In the field of art, the period was known as the Renaissance. Italian Michelangelo paints the Last Judgment in the Sistine Chapel. It took him 4 years to complete the project. The world in general was full of culture, scientific, and mathematical growth during the mid-16th century.